Welcome to In 5 minutes. We take problem on simply supported beam with point load and uniformly distributed load. Our problem statement is a simply supported beam of 8 meter span carries a uniformly distributed load of 2 kN per meter on the left half of the beam. It also has a point load of 25 kN at 6 meter from the left end. In addition, the beam is also subjected to a counterclockwise couple of 20 kN at the left end and clockwise couple of 30 kN at the right end. Draw the shear force and bending moment diagram indicating the principal values. So in this problem, we have not been given the loading diagram. We have to draw the loading diagram as per the information given in the problem statement. So first step is to draw the load diagram. We first take a simply supported beam which has two support reactions, vertical reactions at the two extreme ends, and the span of the beam is 8 meter. Then we draw a uniformly distributed load of intensity 2 kN per meter on the left part of the beam, that is for a distance of 4 meter from the left end support. Then we draw a point load of 25 kN which is acting at a distance of 6 meter from the left end support. And also there are two couples. First is a counterclockwise couple of 20 kN at the left end. So we draw a counterclockwise couple of magnitude 20 kN. Also there is a clockwise couple of 30 kN at the right end support. So we draw a clockwise couple of magnitude 30 kN. So with this, our loading diagram is complete. Our loading diagram must contain information of all the forces and the point and the distances of all the forces about some reference point. So we have all the respective distances also. Now for the sake of convenience, let us define the salient points. Let this point be point A, this be point B, this be point C, and this is point D. So if you see this beam, we'll see that it is a kind of a fixed beam which has on the left hand support a vertical support reaction and a anti-clockwise couple, and at the right hand support we have another vertical support reaction and a clockwise couple. Now since there are four unknowns, we would require at the minimum 3 equations to find the 4 unknowns. Now since we can make use of only 2 static equilibrium equation, hence in the problem they have already given your 2 couples acting at the support. The only thing which we have to find out is the 2 vertical support reactions. Our first step is to find out support reaction. We see that there are only 2 vertical support reactions. So let us name this support reactions as VA and VD. So we make use of 2 static equilibrium equation. First is summation of moment about any point equal to 0. Then second, summation of all vertical forces is equal to 0. Now we first take the first equation and we take summation of all the moments about point A equal to 0. Now from point A we calculate all the moments about this point. Our sign convention is clockwise couple positive and anti-clockwise couple negative. At point A we have the anti-clockwise couple of 20 kN. So this is minus 20 kN. Then about point A there will be a couple or moment caused due to this uniformly distributed load over a span of 4 meter. So the magnitude of that force will be 2 multiplied by 4, and it will act at the center of the uniformly distributed load. Now since the couple or moment due to this uniformly distributed load will be a clockwise one, so we have positive 2 into 4, this gives you the magnitude of force, multiplied by the distance which will be 2 meter, plus there will be a clockwise couple due to the force of 25 kN which is acting at a distance of 6 meter. So we have plus 25 into 6. Then we have here a clockwise couple of 30 kN, so plus 30, and there will be an anti-clockwise couple or moment formed by this support reaction VD which is acting at a distance of 8 meter from point A. So we have minus 8 VD, and this whole is equal to 0. Now upon solving this, we get the value of VD as 22 kN. Now since it is positive, our assumed direction of the support reactions is true, and that is upward. Now we use our second static equilibrium equation, that is summation of Fy equal to 0. Now sign convention is all the upward forces are positive and all the downward forces are negative. So we have the 2 upward support reactions VA plus VD. then all the downward acting forces, first is the force due to this UDL whose magnitude will be 2 multiplied by 4. Then there is the downward force of 25 kilonewton, so minus 25. So all the forces are accounted. So this is the summation of all the vertical forces and this is equal to 0. Now substituting the value of VD as 22 kilonewton here, we get the value of VA as 8 plus 25 minus of 22. This is the value of VD. So this is equal to 11 kilonewton. Again, since V is positive, the force is upward.